Did the sky quietly turn down its brightness and no one told us? What if the northern hemisphere is literally getting dimmer, not metaphorically, but physically? For most of human history, daylight felt like a constant. Sun rises, sun sets, nothing to worry about. But over the last few decades, scientists started noticing something odd. Light levels across large parts of the northern hemisphere appear to be decreasing. Not dramatically, not overnight, but enough to raise eyebrows. This phenomenon even has a name: global dimming. And it's not just about gloomy weather or bad moods. Global dimming refers to a measurable reduction in the amount of sunlight reaching Earth's surface, especially across North America, Europe, and parts of Asia. So, is the planet actually getting darker? Let's unpack what's going on. The first clue. In the 1950s, scientists began measuring sunlight using simple ground instruments. Decades later, they compared notes. The numbers didn't match expectations. Some regions were receiving up to 10% less sunlight than before. That's not a vibe shift. That's physics. At first, many assumed faulty equipment, but the pattern showed up across countries, climates, and decades. Something real was happening. And that led to the next discovery: the invisible sun blocker. The biggest culprit isn't clouds. It's tiny particles floating in the air. Aerosols. These microscopic bits come from car exhaust, factories, power plants, and even cooking fires. They're small, but together they form a massive sun shield. Aerosols scatter sunlight before it reaches the ground. Think of them like a planet-sized Instagram filter, minus the consent. In heavily industrialized regions, this effect stacks up fast. And here's the twist: more pollution doesn't just trap heat. In some cases, it actually cools the surface by blocking sunlight, which leads us to a surprising contradiction: the climate paradox. We often hear about global warming, but during peak global dimming in the 1970s and 80s, some regions actually cooled slightly. Scientists were confused. Greenhouse gases were rising, but surface temperatures weren't climbing as fast as expected. Why? Because global dimming was masking some of the warming effect. It's like pressing both the gas pedal and the brake at the same time. Once air quality regulations kicked in and pollution dropped, sunlight increased again, and temperatures rose faster. That reveal startled a lot of climate researchers. But dimming doesn't just affect temperature. It changes the planet's rhythm. Plants, crops, and photosynthesis. Plants live on sunlight. Less light means less energy. In some regions, crop yields dipped not because of drought, but because of dimmer skies. Here's the weird part. Plants don't just need light. They need the right kind of light. Scattered sunlight from aerosols can actually penetrate deeper into forests. That boosted plant growth in some ecosystems. So yes, pollution briefly made some forests grow better. Nature is complicated like that, but don't celebrate just yet. The human health angle. Less sunlight doesn't just affect plants. It affects us. Sunlight helps our bodies produce vitamin D. Lower light exposure has been linked to higher rates of deficiency, especially in northern latitudes. There's also evidence tying reduced sunlight to mood disorders. Seasonal depression isn't just about winter. It's about light. And if you're wondering whether you imagine darker summers, you might not be wrong. Which of these surprises you the most so far? Satellites, join the chat. In the 1980s, satellites gave us a new perspective. From space, scientists could see aerosol plumes stretching across continents. Massive hazy blankets dimming entire regions. After major volcanic eruptions, like Mount Pinatubo, global sunlight dropped noticeably. Temperatures dipped worldwide for a couple of years. Volcanoes accidentally ran a planet-scale experiment, and the results confirmed it. Particles in the air can dim the world. But here's the important update. Is it still happening today? Global dimming peaked around the late 20th century. Since then, many countries cleaned up their air. Europe and North America now experience something called global brightening. Sunlight levels have partially recovered, but in fast industrializing regions, dimming still occurs. So the planet isn't uniformly darker or brighter. It's patchy, uneven, and constantly shifting. The sky above you depends on economics, policy, and wind patterns. Which is wild when you think about it. The big takeaway is Earth's northern hemisphere getting dimmer. Historically, yes. Scientifically, measurably so. But today, it's more complicated. We dimmed the planet without realizing it. Then we accidentally unmasked hidden warming. Global dimming taught scientists a humbling lesson. Small particles can have planet-sized consequences. Or as one researcher put it, the sky remembers everything we release into it. Logo outro scene.